Hello and welcome back to chemistry. In the last video we were talking about basic stoichiometry, mass to mass and mole to mole calculations. We're going to go into a little bit more detail and talk about limiting and excess reactants. First of all, let's look at this problem. When copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. Write the balanced equation from the reaction given above. Now that seems fine. We've done that before. If 15 grams of copper 2 chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? Okay, this is definitely a limiting reactant problem. In most of those mass-to-mass problems that we did, they only gave us one of these numbers. And then they said we had an excess of the other reactant. What that means is we really don't know in what ratio these things are going to react. Here's my point. I might need to use all 15 grams of copper 2 chloride to react with 20 grams of sodium nitrate, but I might have some sodium nitrate left over. Or I might need all 20 grams of sodium nitrate and have some copper chloride left over. So now we need to figure out which is which. The one that I have left over is called the excess reactant because I have more of it, or excess reagent. The one that I don't have any left over is called the limiting reagent or reactant. It limits how much I can make. So you're probably thinking, how do I figure that out? Well, there are a couple of different ways, but I'm going to show you the way that I think is easiest for students to figure out. Before we do this, let's go back and actually write out this equation. And now we're starting to see that the chemistry we learned in previous units actually matters. Chemistry is much like math. It starts to build on previous knowledge. And if you are shaky in that previous knowledge, it's going to come back to haunt you at around this point in time. So if you don't know how to write out ionic compounds from words, then I strongly suggest you go back and review the video that I did on that or review the book. But we have copper 2 chloride. Let's go ahead and put down copper. We know this has a charge of +2 and chlorine is -1, so I'm going to need two of those. Copper 2 chloride plus sodium nitrate. Sodium, which has a +1 oxidation state, and nitrate's -1, so. And also now we have to memorize these polyatomic ions and charges, so there's a lot of previous knowledge here. It will make copper 2 nitrate. Copper 2, and we're going to need two of these nitrates to cancel out that copper, plus sodium chloride. So now we've written out our equation. Let's go ahead and balance this. CuCl2 plus 2 NaNO3. And yes, I wrote all this out and balanced this before the video. I wish I could do it this fast, but I needed to look at a few things. So we have copper, nitrate, plus sodium chloride. Well, we've successfully done the first step of this problem. Let's leave this here and go to the second step. Okay, we have 15 grams of copper 2 chloride, and we have 20 grams of sodium nitrate. So, here's the best way to solve these problems. It already asked me how much sodium chloride can be formed. So I'm going to do a mass-to-mass calculation with both of these. I'm going to start with 15 grams of copper 2 chloride. So if I start with 15 grams of copper 2 chloride, I will convert it to moles. This is 1 mole of copper 2, sorry, I didn't put my little 2 there, chloride. And then I will have to look up the molar mass of copper 2 chloride, which is 134.446 grams of copper 2 chloride. Now, I need to look at my mole ratio. How much copper chloride do I need to react to make sodium chloride? Well, this is actually a 1, and this is a 2. So it's a 1 to 2 ratio. So I need 1 mole of copper 2 chloride, which reacts with to make 1 mole of sodium chloride. Now I will convert this back into grams. I will find the molar mass of 1 mole of sodium chloride, which is 58.44 grams. And I will do that calculation. 15 divided by 134. I'll just skip that since it's 1 to 1 times 58.44. And I'm going to end up with around 13.040 grams of sodium chloride. Now keep in mind, this isn't my answer. If I use 15 grams of copper chloride, I will produce 13 grams of sodium chloride. But what if I use 20 grams? I will go back and redo this entire problem, another mass to mass, but instead of copper chloride, I'm going to go over here and use sodium nitrate. 20 grams of sodium nitrate. 1 mole of sodium nitrate. And we will go look up the molar mass on the periodic table of sodium nitrate, and I will get around 84.99 grams of sodium nitrate. Yet again, I will look at my conversion factor based on my balanced equation. So 2 moles of sodium nitrate equal 2 of sodium chloride. Well, that's easy for me again. 2 moles of sodium chloride. 2 moles of sodium nitrate. Now I will convert back to grams of sodium chloride. 1 mole of sodium chloride equals 58.44 grams of sodium chloride. And if I do this math, it will end up being about 13.75 grams of sodium chloride. So these are relatively close. Now let me go back and point one thing out. I advise that you always write the units, grams of copper chloride. Then you know that they cross out when you're doing the dimensional analysis. Moles to moles, moles. I see a lot of students not writing out the units, and I think this is a big mistake because this helps you check the problem to make sure you did it right. Okay, the second thing I've noticed that some students do is that they'll find the molar mass, but they don't really write anything down. They just sort of look at the periodic table, do a few quick calculations, add everything up in their calculator. My advice is this. Go to the periodic table. Let's just say we're going to find sodium nitrate. And on your problem sheet, write down Na equals. Then go to Na sodium, 22.99. Now write down nitrogen equals, which is about 14. Then oxygen equals 16 times 3, because there's 3. Do this math and put down your molar mass. The reason I advise that you do this is because then you can go back and check your problem. If there's one thing that people really get wrong a lot is they just make little teeny errors when they calculate out the molar mass. They forget something, they don't multiply something. Trust me, I do the same thing all the time. So if you're doing a test, you really should get in the habit of doing this. Okay, now let's look back at this. If I had 15 grams of copper chloride, I'll make 13 grams of salt. If I have 20 grams of sodium nitrate, I will make 13.75 grams of salt. So what this means is copper chloride is my limiting reagent. I can only make this much salt. It doesn't matter if I have 20 grams of this. Now, if I look at the question, I have 15 grams of this and I have 20 grams of sodium nitrate. So this 15 grams of copper chloride will completely react with this 20 grams of sodium nitrate. This will all be used up. But there will be some sodium nitrate left over. So I can only make this much salt. And if I go down to the next question, it says, what is the limiting reagent for the reaction? The limiting reagent for this reaction is copper 2 chloride. Because it limits how much of the product I can make. How many grams of copper 2 nitrate is formed? All right, now we have to do a whole other calculation. They really like calculations in chemistry. The more they can make you do in one problem, the happier they are. Well, how am I going to figure this out? First of all, I know that my limiting reagent is copper chloride. So I'm going to have to start out with 15 grams of copper chloride. Now instead of finding salt, I'm going to find out how many grams of copper 2 nitrate is formed, which, by the way, is going to be my other product, copper 2 nitrate. So CuNO3 Now, luckily, I can just copy all of this information again from my other problem, so at least I have that. 134.446 grams of copper chloride is 1 mole. But now I need to do a conversion factor ratio, actually, between copper 2 chloride and copper nitrate. So it's 1 to 1, which works out well. 1 mole of copper 2 chloride equals 1 mole of copper 2 nitrate. 1 mole of copper 2 nitrate, and I have to look up a molar mass for copper 2 nitrate, which luckily I've already done, which is 187.546 grams. Of copper nitrate. Now, I do the math, and after I do all of the math on this, I find that I make around 20.924 grams of copper nitrate. Let's go back and review really quick what we did. So far, we had to do 2 mass-to-mass stoichiometry calculations. We did that with the 2 masses that were given, and we found out how much of the product we were looking for in each case. We found the smaller number out of those products, and we assigned that compound as a limiting reagent. So then we just forgot about this for now. We then took the grams of the limiting reagent and plugged it into this second part of this question to find out how many grams of copper nitrate we would get. Okay. Let's go down and see what else they have in this problem. How much of the excess reagent is left over? Well, isn't that wonderful? So, remember, the excess reagent is the sodium nitrate. We have 20 grams of it. Think about that. We know that all 15 grams of copper chloride were used up. However, all 20 grams of sodium nitrate were not used up. Some of this is left over. I don't know how much it is. It could be 2 grams, 3, 4, 1.5. I have no idea. I know I have 20 grams. I know that all of it wasn't used in this reaction. So how can I figure out how much is left over? Well, this is pretty easy. If I know I have 15 grams of copper chloride and all of this is used up, what I could do is do a mass-to-mass stoichiometry problem. I could plug in 15 grams of copper chloride and figure out how many grams of sodium nitrate I used. Then I will know how much is left over. So let's go ahead and do that. 15 grams of copper chloride. And luckily enough, I have all of these molar masses already. So 1 mole of copper 2 chloride is going to be equal to, yet again, 134.446 grams of copper 2 chloride. Let's do our ratio. Copper 2 chloride. So 1 to 2. 1 mole of copper 2 chloride is equal to 2 moles of, 2 moles of sodium nitrate, NaNO3. One mole of NaNO3 is equal to 84.99 grams of NaNO3. Now, if I do this math, I'm going to find out that I'm going to get an answer about 19 grams of NaNO3. So, what does that tell me? It tells me that I was given 15 grams of copper chloride. I was given 20 grams of sodium nitrate, but I didn't use all the sodium nitrate. Remember, I was given 20 grams of sodium nitrate, but I only used 19 grams. So 20 minus 19 grams of NaNO3 equals 1 gram. So I have 1 gram of my excess reagent left over. So yet again, let's go back and review. If I'm given a limiting or excess reagent problem, and I need to figure out which one is the limiting reagent and which one is the excess, I simply take the numbers they give me and do 2 mass-to-mass stoichiometry problems. And by the way, it doesn't matter which one of the products I do. I can do one or the other, because in the end, it's still going to give me the same result. Not the same amount of product, but it will tell me that one is smaller than the other. And then the one that is smaller, like right here, will be the limiting reagent. The one that is larger will be the excess. So you have to do 2 mass-to-mass stoichiometry problems. Then, if you want to figure out how much of the excess that you have left over, you need to identify your limiting reagent and plug that in to find out how much of your excess is left over. It seems like it's complicated, but in the end, it's just mass-to-mass stoichiometry like we've already practiced. You just have to do more of them when you're doing these problems. Now, in the textbook, they have a slightly different method where they only go to moles and then they compare moles. Yeah, you save a little bit of time, but I'm not teaching you that method for 2 reasons. Number 1, I think it's actually a little bit more confusing for high school students, and honestly, it's even a little bit more confusing for myself. Number 2, in almost all of these problems, they're going to ask you how much in grams of a product can be formed. So even if you figure it out right now, you're going to have part of your answer for the second part of the problem. So in the end, I think it works out. So yet again, if you have any questions, let me know. I'll try to do a few more videos on this since it is a little complicated, but I hope this helps you out. And yet again, practice makes perfect. I just advise that you do 4 or 5 of these questions a day and just keep on going. All right, thank you and have a good day.